So now that we've visualized Java futures, now that we've shown an example of applying Java futures in practice, let's step back and talk about the pros and cons of Java futures. And the main thing you're going to see here is that they're very limited in what they can do. That's their primary cons. But let's give them a short shout out for pros, because we're trying to be encouraging here. I once did a work with a company called Accenture. They used to do a lot of work here with us at Vanderbilt on various projects. And whenever they would give reviews, they would always start out by saying what they liked, and then they would always say things that could be improved. So they never criticized anybody. They just said these things could be improved. So we're going to talk about the pros, and then we're going to talk about the things that can be improved. So the pros are you may be able to leverage parallelism more effectively while still having fewer threads. All things being equal, you'd like probably, at least in traditional Java, not to make a lot of threads. And that's because in traditional Java, threads are fairly computationally expensive. They take up a large amount of space, at least virtual space, virtual memory, and they are somewhat heavyweight. With the newer features that are coming as part of Project Loom, which is looming in the horizon with Java 18 or later, then there's a new model called virtual threads, which are much lighter weight. But traditionally, which we're talking about here, Java threads are fairly expensive, so you'd like to avoid having too many of them if you possibly can. So one of the things you can do here is you can have a pool of threads. Like you see here, we have a pool of threads, let's say 4 threads, probably matched to the number of cores on your machine. And then we're going to go ahead and submit tasks that we want to run asynchronously. And so they'll basically be queued in this work queue here, the work queue, for later processing by one of the threads in the pool. So you can queue computations for execution in the pool of threads, and then those computations will run asynchronously with respect to the caller that submitted them. Another nice thing you can do by having a pool of threads is that the threads can be automatically tuned. So if you, for example, if you select the cached thread pool, then it will create threads as needed as work comes in. And if there's threads that have been created before and they're currently idle and new work comes in, then rather than going ahead and creating new threads, it'll simply recycle and reuse a thread that already exists. So the threads can be automatically tuned, which is very nice. And then you can get the results off the queue of the completed futures and do something with them. And there's a bunch of different variants. It's beyond the scope of this class to go into this in detail. My sibling class in the spring will cover this in great detail. But with something like an executor completion service, you can get the next completed result off of something called a completion queue by taking it, and then you can go ahead and call the get method on the future that came back. And in that case, the future is already going to be completed because it wouldn't show up in the completion queue unless it was completed. So get is just there simply as a syntactic mechanism to get the results back from a future and also to be able to handle errors in a consistent way. The other thing you can do with Java futures is you can block until the results of asynchronous two-way tasks are available. So we saw that example when we talked about the use case in practice for the big fraction multiplication. So you can call get, or you can call get with some kind of time unit and some kind of timeout amount. And the idea of this, by the way, is to help make your asynchronous programs more responsive by not blocking for an undue amount of time. If it's going to take a long time for something to run, you might want to do a timed wait. If you get lucky, you get the result, you wrap up, or you go on to the next phase. If you don't get lucky, you go off and do something else until you come back around again and try to get the result. And there's also a bunch of other methods like is done and is canceled and cancel that can be used to make asynchronous programs more efficient with respect to resource usage. So if you really know you're not going to wait around for this computation anymore, you don't need it, you can cancel it, thereby freeing up the resources for use with other parts of the program. All right, so those are the pros. Now let's talk about the cons, or the things that could be improved. And in fact, they are improved with Java completable futures. So one of the big problems you have with Java futures is their limited feature set. There's only these 5 methods: cancel, is done, and 2 variants of get. And these come with all kinds of limitations. In particular, you can't complete a future explicitly. You need to use other mechanisms like future task, which is convoluted and beyond the scope of this talk anyway. So you can't create a future, do a computation, and then explicitly complete it. You also can't chain futures together fluently. Remember when we've been talking so far about things like Java parallel streams, and you have say a collection and you say dot stream or dot parallel stream, and then you chain together a bunch of intermediate and terminal operations like filter and map and drop while and limit and collect and so on. Those are chaining them together. And because of the way that futures work, you can't have dependent actions triggered when a previous action finishes. You always just have to say get on a future, and you can't chain those things together in any sensible way. So that's a really big limitation. You also can't trigger the futures reactively. You have to use either waiting, blocking, or timed waiting, or polling. And all of those things are very, very problematic. Even though they kind of work, they're very problematic. And here's the problem. Whenever you start using blocking, then you have the problem that you may wait for a long period of time, and if the computation takes too long, you're kind of freezing out that thread from doing any other useful work. And if you start using timed operations, like wait for 10 milliseconds or doing polling, return right away if I can't get what I'm looking for, that's almost always the wrong thing to do, because it's very hard to anticipate how long you should wait. So either you're going to wait too long, in which case other parts of your program become non-responsive, or you're not going to wait long enough, in which case you're kind of spinning and neurotically asking the future, are you done? Are you done? Are you done? Very impatiently. So that's almost always the wrong thing to do. And that's all you can do with Java futures. Another thing you can't do is you can't treat collections of futures efficiently. So for example, here we've got two computations that run asynchronously, and we'd like to get whichever one finishes first. Whichever, if it turns out that future 2 finishes first, we want that one. If future 1 finishes first, we want that one first. But the way that futures work, you have to call them in a particular order. And if you call future 1 first, but future 2 finishes first, you're going to have to wait for future 1 to finish before you can get the result from future 2. There's no way to be able to treat collections of futures in a very convenient way, just by using futures. There's other stuff we'll talk about later that would allow you to do that. So in general, the big problem here is it's awkward and inefficient to compose multiple futures together. The composition doesn't work. It's like putting pieces of a puzzle together that don't really fit. These limitations with futures motivate the need for the Java completable futures framework. So going back to my earlier point about what can be improved, these are all things that can be improved, and in fact, they are improved, and we'll talk about that starting next class when we start talking in earnest about Java completable futures, which fix all of these quirks with Java futures. And that was intentional. When Java futures came out, they knew they were not the end-all be-all, but they wanted to get something out at the time, and as often the case, something that works is better than the perfect thing that takes another 5 or 6 years to come along. So indeed, when futures were released in 2004, it took about a decade to get completable futures, which are a much, much better way of doing things. But they didn't have enough time and enough knowledge at that point to do it effectively back in 2004, so they put futures out first.